I know that I have mentioned in the past that I'm not really that interested in going to space, but actually I feel like I might change my mind if I can quit my job and then 15 days later go to space as well. So let me know, David, what you think about that. If you're going to be able to give me the money to buy Jeff Bezos's extra seat on that flight, or if I can quit my job and then just like do that really quick and then come back, or like what the deal is. But I wouldn't mind going to space with Jeff Bezos. Anyways, this is the HackerNoon Podcast, and my name is Amy Tom. Today, I am joined by Yoz Grahame, who is the solutions architect at LaunchDarkly. Is that right?
Hello.
A solutions architect. We did it again. Oh my goodness. Anyway,
it's all right.
This is round 2 for you on the HackerNoon Podcast. Welcome.
Thank you so much for having me back.
And so today I want to ask you a bit about bugs. So I know last time we talked about feature flags and a bit about your career, but I guess I'm not a developer, as I've mentioned many times in the past, but I am curious about learning more about bugs, and I guess I'm kind of curious too about how you've gotten this domain expertise in bugs and what your interest in it is.
So it's something that came out partially because as I get more experienced as a software engineer, and as I said last time, I think this is a typical journey for software engineers, is that you go from being frustrated when something doesn't work to being amazed that anything works at all, because you see the huge amount of complexity. And this complexity is only getting greater and greater with each passing year. We see systems being built on top of systems, right? There's so many increasing layers that are involved in every system now, because there's so much interoperation between different ones, right? You have these days, when you build apps, you're using APIs that talk to multiple services on the internet. You're using libraries on top of libraries on top of libraries. Just building like your average Node.js application, you pull in like 5,000 libraries when you do npm install or something, because everything's on top of everything else. And bugs are a fact of life with software engineering. And what happened with me is that I got fascinated with debugging, because I came to realize that there are aspects of debugging that most engineers are not taught, and in fact are given directly bad advice about how to debug. What I think is, I mean, much of it is very opinionated, and certainly this is all going to be my opinion, but I think there's a lot of stuff here to go into. I think it was, but also seeing that bugs themselves are fascinating. And to me, I think there's something that happens for many of us, which is we enjoy interesting surprises. We enjoy the kind of, it turns out that actually this thing you thought was true is false. There's this bizarre other thing. And bugs are being confronted with that kind of turns out every other minute, right? You think your code is going to work a certain way, and it turns out it does something different. But then when you see the effects of bugs on a wider scale, or that manifest in really weird ways, it's fascinating, right? It becomes a new kind of natural phenomena, right? It's a new kind of environmental phenomena in the same way that kind of rains of frogs, right? There have been times in history where there has been a shower of frogs on a village that this is an act of God. And no, it turns out that there was a tornado or something that managed to traveled over a lake, picked up a huge amount of frogs or fish, and then later on deposited them over a village. And it's a culmination of a whole bunch of weird events happening together. And bugs are like that. Sometimes you get these amazingly fascinating and sometimes hilarious, sometimes tragic stories. But ultimately, it's something that we need to bear in mind, because I think that quite often engineers, so we start off with that feeling that frustration when something doesn't work, because you have the expectation that you understand how the system works and therefore it should work, and it's annoying when it doesn't. And to many of us being, and I'm still consider myself after 20 years in the industry, an intermediate programmer at best, is is we need more humility around it, because the chances are that something won't work. And if it looks like it's running fine now, it's mainly because you haven't hit the bug yet. You know, and so being more careful about this and understanding the different ways that bugs manifest is vital.
As a
and
developer, could you point the finger to someone on your team and say that bug was you?
Sometimes you can. Often you can.
And is it like a taboo, or like are you looked down upon for making too many bugs, or what's like dev culture like around that?
These days, fortunately, there has been a movement to what's known as a blameless culture, which is not, a lot of people misinterpret it as saying that nobody ever gets blamed, and that's not true. You can have people who are bad, or at least bad, not themselves bad, but do bad work,
bad coding
consistently, and they should not be doing it. But the good thing about a blameless culture is that the idea is that you're continually learning. Everybody is continually learning, and everybody is dealing, you assume best intent on the part of everybody using the system. And in the case of a horrifically complicated system, there are so many ways that things can go wrong. And most bugs are the result of entirely understandable misconceptions. You have one of the bugs that I demonstrate when I'm teaching software engineering to people who join our company. And I do a very quick primer in software engineering to all employees, including, because, only a third of us at LaunchDarkly are actual software engineers. But we're all working in the software industry, and we make a product that is used by software engineers and other people as well. So it's important to understand the basics of software engineering. And to do that, you need to understand why software engineering is so complicated, and it is so complicated because bugs. Right. So, start somebody off with like a Python program. I demonstrate a really simple few lines of Python code that implement a bank account. Right. I use a floating point number to store dollars and cents. So I say, you add, I don't know, I add $1 to the bank account. So it goes from 0 to 1. And then I add 0.2 of $1, so 20 cents. And then I subtract $1. I can't remember the exact sequence of events. And then you print the value of what's in the bank account, and it should be 0.2, right? It should be 20 cents left. And what it actually shows you is 0.1999999. And the reason it does that is because of the way that floating point numbers work in computing. But ultimately, the reason is that your conception of how something works in the computer is different from how it ultimately works. And those tiny differences, those little edge cases, most of the time, that would work fine. But there's a sequence of different kinds of computations you can do with floating point numbers where it will produce something that is not a properly rounded number. Right? It's a surprisingly common thing. And it turns out this is exactly the kind of bug that ended up killing about 30 American soldiers during the original Gulf War in the 90s with the Patriot missile, where it had something in the guidance system that was using floating point numbers the wrong way. And if you ran the system for too long, its targeting would go off enough that it would literally miss the thing it was aiming at and accidentally hit people instead. And so we have these very simplified ideas of how systems work.
The horrific side of the bug. Exactly.
Yeah. And things like this. But, that's a really simple technical one. Quite often the bugs come from a higher level misunderstanding of how users are actually going to use the system and how they do actually use the system. Right? Yeah. And this bug can happen not at the code level. It can happen at the design level. It can happen at the product level.
What's an example of a more lighthearted bug, perhaps?
So, I've got so many of these.
I feel like you have a database of bug knowledge in your mind.
I do, because I started collecting. I mean, it's not a great database. I confess it's very leaky. But one of my favorite funny stories. So I spent 5 years working at Linden Lab, which is the company that creates and runs Second Life, which is a 3D virtual world. Now, virtual worlds and games have some of the funniest bugs, right? Because they're trying to model in some ways a real world. And then bugs mean that things happen that are so unlike the real world, they are completely hilarious. So one thing that happened in Second Life, Second Life itself is not just, people think of it as a game, but it's not, it's a platform, right? You can't actually win or lose in it. And there's real economy. There's a floated currency that floats against the dollar. So Linden dollars, which are the in-world currency. There are people who literally make an entire living off Second Life businesses where they produce things in Second Life and they sell them and it makes them enough money to live, right? So there are all kinds of different products, and one of them was the virtual pets, or breedables as they're called. So one kind of virtual pet, and the model is for these things is very much like the Xerox model of get the printer but pay for the ink. And in this case, it's get the virtual pet but pay for the food. Right, pay for the food to keep this thing alive. And this was this beautiful kind of Arabian horse that somebody was selling, and it was very expensive. And the people have these horses, and the idea was you have the horse, you put the food out, and the horse then makes its way to the food and eats the food, and that's how it stays alive. Now, one day, we in Linden Lab pushed a very tiny change to the physics engine that did this. You see where this, you may, I love telling this story and seeing people jump ahead and they realize what's going to happen. It's beautiful. Tiny change to the physics engine that changed the friction of how objects move along the ground. Now, the way that the horse found the food is by using what in games is called a pathfinding algorithm, right? Where you've got a bunch of objects around in the environment and you need to be able to make a path to get to the thing you want to get to, right? Now, unfortunately, the pathfinding algorithm was using the old friction value to power the horse. So what would happen is that horses literally started sliding past their food. And sometimes they would slide so far, they would slide off the in-space platforms they were sitting on and kind of disappear into space. I imagine them kind of whinnying and pirouetting as they go, these horses flying off.
These beautiful Arabian horses disappearing into the abyss.
Well, exactly, right? Imagine this rain of horses instead of frogs, right? Just flying off. And this, I should say, this sounds hilarious because it is. It's absolutely hilarious. Unfortunately, it was also literally tens of thousands of US dollars worth of merchandise that was virtually disappearing because of this bug, right? Tens of thousands US dollars worth of virtual horses. And so our QA team, our server QA team literally was up all night rolling back server states to rescue virtual horses from starving to death.
Oh my gosh.
It's so good. This wasn't even there's another one. I mean, there's one that to me we had great bugs in Second Life to do with virtual world and misbehaving, right? You can accidentally, we literally had a bug that took us years to track down in which people's avatars would, for no reason we could understand, suddenly bend over and stick their own heads up their behinds.
Oh, it took you years?
Yes, it took us years to understand why this was happening.
Who did that?
It was really rare, right? But when you have enough people using the system, it means it happens every day. And they complain about it. And then once you go in, all the evidence is gone, right? And so you need to, this is part of the problem of debugging, is actually capturing something in the act. Okay, this is one of the hardest things because you want to be able to observe the system when it's happening. This is why, for example, I'll give a shout out to my friends working on observability, such as Honeycomb. Why this stuff is so valuable, because you're accumulating the actual data points that you can use to debug the system rather than the effects. But there was one, and to me, I love this story because it's kind of a potted history of computing in one bug. The update system, Second Life had a client that you would run on your computer, right? And it would have a built-in update system where it would download, a new version of the software when there was one and update it. Unfortunately, it was a really hacked together update system. It was not well built. And what it would do is it would literally just call up a URL. The code would call up a URL on the web from our server and download whatever it saw there and then run that. Because what was meant to be there was the new version of the software, right? Unfortunately, one day there was a server misconfiguration, and if you access that URL, you actually got a 404 not found error, right? Mm-hmm. Unfortunately, the software did not check what it was getting, did not validate what it was getting. So it downloaded this 404 page and saved it as an executable program and then tried to run it. So this is on Windows, and Windows normally has a way of, something should look like an exe, or like a .exe file. But there is from the history of Windows is based on DOS. And in DOS executables were called .com files. This is from the 80s. And unfortunately, they didn't have a particular way they started. It could start in any way. There was no real way to check. And Windows, when you told it to run this program, it didn't actually check what it was running. And so it would run this 404 page as if it was a program, right? Because binary data can be interpreted any particular way. If you say this is a web page, it'll try and load it as a web page. If you say it's a program, it will try and interpret it as instructions to the processor.
Yeah.
Okay. Now, if you did that with this 404 page, what it turned out it actually meant is it would open the printer port and then spew a whole load of garbage to the printer. Now, if it was a decent printer, it would check what it was getting. You may notice a pattern here of not checking things correctly before doing stuff on them, which is a continual problem in software, right? We tend to make the assumption that things are going to be okay when we get data, and when they're not, that's how so many bugs happen. A huge class of bugs and security holes is in not checking what you're getting. And in this case, most printers would reject it, but a few of them would go nuts. And in one case, at least one case would physically break. So there was a version of Second Life that would download a new version itself, failed, and then break your printer. Like, as in you had to throw the printer out. It was gone. Right? And
my gosh.
The thing is, it's like, this is what I talk about houses of cards, in that we're talking, this is something that involves a web failure. This involves a Windows, DOS, history of printers, everything occasionally comes together in exactly the way that both works really badly.
Yeah. Yeah. That's interesting. And so let's talk about why it takes so long for bugs to get fixed. This is my assumption, being a non-developer, is that it must be a chicken and the egg scenario where upper management says you've got to go faster to please the shareholders and do more features, and so the old ones just don't get fixed. You just keep going. Is that accurate?
Somewhat, I'd say. Okay. I mean, the thing is, that's a very common story, and I don't think it's a continually true one. I think it's often true. I think there are many bad bugs that have happened because of that. I think the nightmare bug, which we should visit later if we have time, is a great example of that, where upper management pushed and then ended up destroying the company with a bug because there was just too much pressure. And we've seen that with other systems like the Challenger disaster. We have this with physical failures as well, engineering failures. There's an amazing book I strongly recommend called Inviting Disaster, Lessons from the Edge of Technology by a journalist called James Chiles, Chiles, which is one of the best books on technology failure I've ever read, because it's full of brief stories that are really well written, and you see management failure, you see technology failure, and it's always multiple things failing. Most systems are resilient to be able to handle individual failures. It's when two failures happen at the same time in different ways that things really start to go wrong. In this case, when talking about bug pressure and in terms of the pressure on engineers to not spend time on fixing bugs, there is a degree of that, but also I think there's many other things to blame as well. I think our tools are terrible. I think software engineering tooling, our programming languages, our debuggers, our runtimes, our systems, everything should be so much better for debugging. Everything is based on the idea that stuff should generally work. And this is not true, right? It's true that good systems tend to work the way they're meant to the majority of the time. But when that time is so great, right? When you're running systems for years, there's going to be thousands of edge cases where things fail. And sometimes those failures can be really minor and aren't worth fixing. And some of the times they can ruin people's lives. There was a bug in so I got involved in government for a while. I was in the US government, and this was shortly after I was in an amazing group called 18F that was about revolutionizing how government does technology. And the great technology failure story of the past decade is healthcare.gov, right? Obamacare, and how it was initially a failure, and then a whole bunch of tech people jumped in to save it, and it became a success. Now, the stories of what they found were horrific, and one of them, which I think I'm free to say because I was not there, and I'm not going to attribute anybody, is that families would sign up and try and register for healthcare.gov, and there would be an error that told them to come back next week. And they'd be queuing up at hospitals or places to do this sign up, and they'd be told to come back next week. A lot of the time, the bug that the code wasn't, again, treating input properly. And in this case, there was a bug where it wasn't handling apostrophes in names. Now, apostrophes in names are a really common thing, right? But programmers are really bad often at handling edge cases and thinking through edge cases, especially when they're on a tight budget or they're working for a contractor or something. And government work, unfortunately, has a bad reputation, mainly because of contractors and people just trying to get stuff good enough for government work. That's where the phrase comes from. In this case, they weren't checking the input correctly, and errors were causing apostrophes were causing errors. But even worse, it wasn't just that. It was that the error wasn't being escalated correctly. So instead of the error being reported in a way that says this has an apostrophe in it and there's a problem, we can't handle apostrophes, it was just saying something was catching all of these errors and just going, the system must be down somewhere, just tell them to come back next week. And so these poor families are coming back week after week trying to get health insurance to live. Okay. And this one bug, which wasn't being reported properly, it's not just, I really want to be clear about this as well, because a recent passion of mine is error messages. And it's amazing to me how many fewer bugs there would be and how much easier they would be to fix if error messages were better. There are programming languages now. Elm is an obvious example. It is one, a little known front-end language that this one guy, Evan Zaplicki, did and still does. And one thing he did was he revolutionized how error messages should look. We are used to seeing error messages that sound like they should be read by a Dalek. Something like it's incredibly like integer out of range, whatever that means. And it won't tell you what the problem is. It won't tell you what the integer is. It won't tell you what the range is. It'll just say that. Python, which is meant to be a beginner programming language, is horrific for this. So Elm comes along, and when you get an error, it gives you a really readable page of English showing your code, showing exactly what's wrong and why it's wrong. And it's beautiful. I've never thought there was such a thing as a beautiful error message until I saw this. And then I realized how much better our world would be, how much better programming would be if error messages looked like this. So now languages like Rust, the very popular, increasingly popular language out of Mozilla, took that on board, and they've made their error messages look like that. But most don't. And it's not just about the bug failure, about the apostrophe. It's about how we find those errors, how they get reported upwards in a way that they can actually be acted on.
Yes. And that's why I think it's interesting that you say that the tools are also part of the problem, because developers and bugs is like, they go hand in hand. It's one of the age-old problems of being a developer, and there are so many different solutions that specifically help developers code better, code faster, code more efficiently. Many, many different kinds, LaunchDarkly included. So I think it's interesting that you say that the tools are also the problem. Why do you think that is? If these tools there's so many that are supposed to help developers become better.
Because I think that most of them, unfortunately, come from a an environment, I think this is a systemic problem in all meanings of the word, in that we developers have been trained on really badly designed tools. And then we don't raise our expectations. We're used to that. We think that that's part of the training. We think that that's part of the culture, is that you should be able to think through bugs without needing to use a debugger that actually works. And these days, my attitude is, since discovering how much time a good debugger can save, and I think there are very few genuinely good debuggers out there, once realizing that, it really changed my expectations of what tools should be doing. There's an amazing talk that a lot of people refer to now, and I really recommend watching the video for this. A guy called Brett Victor, who's become a hero in certain parts of programming. He was an interface designer at Apple for a long time. Not just interface, came up with all kinds of amazing things. And he gave a talk in 2013 called Inventing on Principle. And sometimes you see demos that have tools that are so amazing, you find yourself clawing at the screen to get this thing that is in the demo. It's like, I want this right now. This would make my life so much better. Truly great demos do that. This is a truly great demo. Inventing on Principle has some of the best product demos I've ever seen, because it totally changes your opinion of what tools can do for you as a programmer in terms of how immediate they should give feedback for something going wrong, or how immediate they should let you play. Right? It changes. So the thing that when you see what tools could be doing and aren't, when you start to look at error messages, we instead of accepting error messages that are phrased as integer out of range, so it's being phrased in Dalek speak, but actually say, you could put this in English. You could actually tell me what the problem is. There's information you're not giving me. You start to realize that a lot of it is kind of laziness, and understandable laziness. I don't want to blame people who are under huge pressure to create complex systems, but there is a laziness there that these systems should be telling us more about why things are failing. Now, so I think there's huge potential for many different kinds of tools. LaunchDarkly, putting for my employer, also, but feature flagging in general, not just LaunchDarkly feature flags. Any feature flagging system can be really useful for helping you both turn off and on features when there are bugs. So you can, it means you can turn on a feature when you turn off a feature when you discover there's a bug in it. You can turn on a feature gradually to find bugs without exposing everybody to them. You can do things like control the level of logging in your app dynamically, or control observation. There's actually, giving this talk. I mean, we're talking now. It's Wednesday, 9th of June when we're recording this, if you don't mind me saying, or we can edit that out if you want. But right now there's something called ObservabilityCon, or OllyCon. And there's actually a talk on conditional distributed tracing by a guy called Will Sargent from Eero. Sorry, I have this in the window over here. But the idea is that you should be able to dynamically change the amount of diagnostic data coming from your app without needing to restart it, so you can actually see what's happening. But it's ultimately, I think there are major cultural issues and systemic issues. I think that as developers, we expect too little, but also we think of ourselves, there's this idea of power users. You ever heard the term power users? I don't think the power user is a real thing. I don't think it's a persona. I think, or rather, I don't think it's a type of person. We think of it as a type of person, but actually what it is a type of motivation, right? In that it's like, and this is where you get typically sexist, ageist stuff coming up, like grandmothers. I could teach my grandmother to do this, right? Now, I've met grandmothers who don't know how to configure their email, but they can absolutely kick your ass on eBay, right? Yeah. And it comes down to, are you fully motivated to use this one system? I'm sure you have things, technical things, that you are way better at most people at using, but you might not think of yourself as a technical person, right? And so we developers, we somehow get taught that we are the, masters of our domains, or we are the leaders who should understand these systems, and we don't need nice interfaces. We don't need, and we do. UX design applies to everybody. Information design applies to everybody. And developers somehow thinking that they need to work with incredibly minimal systems and get very small amounts of information is
so true.
unhealthy.
Why do developers develop the ugliest things for themselves, but most beautiful software for everyone else?
Well, I mean, the beauty tends to come from designers rather than, I mean, it depends. It depends where you consider beauty. I think there's beautiful stuff created by developers. And those things, those generalization there. And there's obviously great overlap between the two. But I think there are different cultures within computing. One that I really admire is in games programming, which in many ways is a hugely poisonous culture from the business end. But games programmers have become really good at building custom tools for themselves to work on individual parts of a game that they are making, right? And building visualizations and things like that. I think, honestly, a brilliant trick to be able to do is to write your own debugger for your system, because you will need to debug it. I want to say debugger, I don't necessarily mean at a line-by-line code level,
Yeah,
or it is
okay.
fascinating to write
Can we get to like what's your best working definition of what a debugger actually does?
A debugger is something that shows you information about the internal state of a system in such a way that you can solve problems.
Okay.
Right? So, and this may be a transient thing, because the trouble is that state of a system changes over time. So ideally, a debugger should be able to show you a time series of how something, or you should have control to be able to move both forwards and backwards in a time series to be able to say, how did this change over time? Right? Now, a debugger doesn't necessarily, we tend to think about debuggers as debugging lines of code. It could be debugging something at a higher level in your system. It could be debugging user state. It could be whatever. But put it like this, the time I have put into writing debuggers for any system that I've been building has always paid off. Every single time. It's been worth the initial effort I put in, because it has ended up saving me multiple times and ended up paying off hugely in time saved when debugging things later. And this is something we see it often. The tools we see in game development are more about building than debugging, but there's often an element of debugging in there as well. There's things, and this is where in the previous episode I talked about the value of learning something different in university than computing. Yeah. And I think it is always fascinating to learn from other branches of engineering and to learn from other branches of other disciplines entirely. It's fascinating to see things like in data science, where they're using Jupyter notebooks or the notebook format, which is this kind of series of live evaluated code where you type in command after command after command. That is hugely powerful. Other parts of computing are now going, you know what, that's a really interesting idea. We should use that for other things. I think there are loads of things to do with visualization, things to do with the different ways to bring information out of a system or to make it queryable. This is what stuff like Honeycomb is good at, is to say, you know what, and I think this is a huge part of the power as well, is that one of the reasons that developers try to be minimal about stuff is because we're used to dealing with systems that have very little memory or very little disk space. And these days, there's much more memory and disk space to play with. Yep. So it's actually okay to be logging far more data, right? As long as you've got a way to query it. And this is kind of what Honeycomb does, is that they say, just give us huge reams of data from your system and we'll make it queryable. It's fine, you know? And because it turns out that because the trouble is that we tend to say we're not going to save that data until we start needing it. And then we turn debug mode on. And at that point, it's too late. We've missed the bug that was happening. Right. Yeah. But if your system is continually logging that data, then you can go back in time. Does that make sense?
Yeah. That makes sense. Then you can kind of like identify when you went wrong, is what you're saying, right? Mm-hmm.
Yes, exactly. You want to be able to look at the past. The fact is that most bugs are really transient, and you need to, it's most of the work in debugging, honestly, is coming up with a reproducible bug, right? Coming up with a test case that reproduces the bug every time. There are so many bugs we've encountered which just we can't come up with a repro, you know, because until you get a repro, you can't be sure that you fixed it.
Yeah, makes sense. All right. Well, bugs. I feel like I've got it. I think I feel like I have cracked open your little repository of bug information.
Thank
taking
you.
a little bit, gotten into my brain. I'm ready. It's got this. Feature flags. I understand now. Thank you so much for helping me.
Thank you.
Where can we find you and what you're working on online?
So I work at LaunchDarkly as a solutions architect. I was also developer advocate and did lots of videos for LaunchDarkly and involved in other things as well. I am on Twitter. My username is YOZ or YOZ, Yoz, 3 letters, useful.
Whoa.
Yes, I was very lucky.
When did you get that?
2006. I know.
Yeah.
Jumped in early.
Nice.
I also got Yoz.com as well in 1996.
Nice.
So I've been very
lucky. Is Yoz not the name of WordPress's SEO thing as well?
Is it?
I think so.
I did not know that.
So yeah, I think it's called Yoz. So
okay. Wow.
You got it. Maybe one day they'll buy it from you.
Yeah. I occasionally get offers on it. I have yet to, find one with the right price.
Yeah.
But, maybe WordPress, good company.
Hit him up. You know his Twitter handle.
Oh, yeah. You can come to me, WordPress. Let's talk. I'm ready.
All right. And LaunchDarkly, we can find that at launchdarkly.com. Okay.
Mm-hmm. One word,
I will
LaunchDarkly.
put all of that in the show notes. Thank you very much.
Thank you so much, Amy.
If you like this episode of the HackerNoon Podcast, like it, share it, subscribe to it, and don't forget to send it to your friends. This episode was edited by audio wizard Alex, hosted by me, Amy Tom, and produced by HackerNoon. Thank you very much, and I will see you on the internet. Goodbye.